I'll probably spend 2 days in this section. 1-6 is a pretty quick lesson, so that'll just take 1 day. And I'm guessing early next week sometime, probably a quiz over 1-4 to 1-6. We'll talk about that more a little bit closer to time, but it's about time for one of those. So we'll get there pretty soon. But we've not had infinite limits before, so I need to give you some info about infinite limits before we get started. So this is 1-5 part 1, and I'll start with a definition. It says an infinite limit is a limit in which the function increases or decreases, a limit in which the function increases or decreases without bound, that means forever and ever, as x approaches c. C, again, is the x value that you are concerned about, the one that looks like there's a problem. A limit in which the function increases or decreases without bound as x approaches c. Okie doke. Now, just reading the definition, it's still probably very unclear what an infinite limit is. So I'm going to put up here a function, and you can maybe write this down too. It's not really example 1 today, but it's a good example of a function when it comes to infinite limits. So it's going to be f of x equals 3 over x minus 2. You can graph it on your calculator if you want. I went ahead and just kind of put the graph up here so we can look at it together. You don't feel like you have to recopy the graph. When you look back at your notes, you could just kind of graph that and look at it. But this is what it looks like. It's a rational function. There appears to be a vertical asymptote where x is 2. Maybe even a horizontal where y is 0, but that's what we're looking at. Now, I want to put up here some, and this is maybe something you would want to write down. I'm going to put some limits up here, different limits that I want you to find from this graph. We're going to do this together, but the first one is the limit as x approaches 2 from the left of this function, 3 over x minus 2, but only from the left. Okay, so this is where x is 2. We already talked about that. It's a vertical asymptote. Now, as we approach 2, coming in from just the left-hand side, look at what your function is doing. It is decreasing without bound. It's going to keep going down forever and ever. The closer you get to 2, it's just going to keep going down forever and ever. So we would actually call that limit negative infinity. This is like the exception to the rule when we said, a limit is a single y value. Negative infinity is more of a direction than a value. But again, if you are going down forever and ever, we would call that limit negative infinity. An infinite limit basically means that your answer is an infinity, either positive or negative. Okay, so let's do a couple more here. I'm hoping this will help it make more sense. For the next limit, we're supposed to approach 2 from the right, and it's still the same function, 3 over x minus 2. coming in from the right. Well, here's 2. So as I get closer and closer to where x is 2, my function is going to increase without bound. It's going to keep going up forever and ever. So we could call that positive infinity. It's going up all the way forever and ever. Okay, now, this is from the left, this is from the right. We should probably also talk about what happens when you're coming in from both sides. So this is just the limit as x approaches 2 from both sides of that very same function. Okay, well here's where things don't work out quite as well. If I'm coming in toward 2 from the left and from the right, those 2 limits are not agreeing with each other. From the left, it's decreasing without bound. From the right, it's increasing without bound. So we would still say that the limit overall just does not exist. On something like that, you could do the one-sided limits using infinite limits, but you can't do the limit from both sides. Okie doke. Now I want to show you one other function here before we actually start the examples. So kind of do what you did last time. You can write this down, and so later on when you look at your notes, you'll remember what the function was and you can type it in if you want to. But I'll go ahead and put the graph up here so we can look at it together. You really don't have to recopy the graph right now. We'll just take a look. It's the function -1 over x minus 1 squared. And this is what it looks like. Okay, well, first thing I want to do here, I want to find the limit as x approaches 1 from the left of that function. Just from the left. Well, what do you think it's going to approach as you come in toward 1 from the left? Yeah, it's going to decrease without bound. Going to go down forever and ever, so negative infinity. Well, what happens when we switch that over to the right side? What value, or I should say what y value are you approaching as x approaches 1 from the right? It's another negative infinity. It's just going to keep going down forever and ever. And actually, on this graph, if you were to find the limit coming in from both sides, they are going to agree with each other here. It's not D and E. If you come in from the left and from the right, both sides are decreasing without bound. So we could say that is negative infinity. Okay? Hopefully that kind of explains a little bit better what infinite limits are. Any questions about that first little part? Okie doke. Well, let's try some of our own here. This will be the directions for the first 2 problems. And it says, determine whether f of x approaches infinity. Determine whether f of x approaches infinity or negative infinity as x approaches 3 from the left and right. A little wordy. Determine whether f of x approaches infinity or negative infinity as x approaches 3 So there's two limits that we'll have to find on each of these problems. We want to come in toward 3 from the left, and we want to come in toward 3 from the right. So here's the first one, and it says f of x equals 1 over x minus 3. 1 over x minus 3. Now, I'm going to go ahead and write just a little bit up here so you can kind of see what we're doing. We need to find the limit as x approaches 3 from the left of that function. So I'm just kind of writing that out here. I'll fill in my answers here in a second. We also need to figure out the limit as x approaches 3 from the right of that function. It doesn't say anything about coming in from both sides. So I know what I'm supposed to do. Now I just need to graph that function and come in from the left, come in from the right. If you've got a calculator, you can go ahead and do that. I'll put mine up here. And be super duper careful with your parentheses. It's 1 divided by parentheses x minus 3. And here goes nothing. From the left, I'll do that part first. What would I say the limit is as x approaches 3 from the left? Yep, you're going to follow it all the way down. So negative infinity for the first part. And as you approach 3 from the right, it's going to increase with outbound. So that would be positive infinity. If it had asked for the limit overall, I would have to say that it does not exist, because those two limits from each side are not the same. Yes? Oh boy. All right, we may have to hit a zoom here. I'll put the second one up if you want to go ahead and start to graph that. Our window may have been off a little bit. I just went back to zoom 6, and then that moved to me there. So, yep, you're welcome. All right. Now, number 2 is actually similar, but instead of 1 over x minus 3, now it's 1 over x minus 3 squared. So again, we have to come in toward 3 from the left. So I'll have one answer over there. And then as x approaches 3 from the right of 1 over x minus 3 squared. Let's go ahead and do that. Now, I actually might cheat a little bit here. Can't believe it, but I think I could probably go over there and maybe just hit squared. You probably don't have to put parentheses around the whole denominator. The parentheses are already kind of there, and it's just going to square that part anyway. So this should be fine. All right. Now, as you approach 3 from the left, what would you say your limit is? Yep, it's probably getting pretty easy by now, hopefully, to see what's going on. From the left is positive, from the right is positive. If they asked me for the limit over all, I would say it's just positive infinity. There we go. No negative sign, that didn't look good. Any questions about those two? All right. Very easy to see as long as you've got the graph in front of you. Now, the last part of the lesson is not necessarily going to be these infinite limits anymore, but if you noticed with all of the graphs that we saw from that part, they all kind of depended on the vertical asymptote. All of these graphs, even the ones we did at the very beginning, had vertical asymptotes. And so the last part of the lesson today is going to be finding vertical asymptotes. So I've got a little bit to write down first, and then we'll do some. It says, if f of x approaches infinity or negative infinity, if f of x approaches infinity or negative infinity as x approaches c from the right or left, if f of x approaches infinity or negative infinity as x approaches c from the right or left, then the line x equals c is a vertical asymptote. Okie doke. That's what we're going to be looking for with the last few. Now, I've also got something up here to show you that will kind of help us when we start to do our examples. So after this part, we should be good to go with the directions. But it says a function h of x equals f of x over g of x, they're all rational functions here, has a vertical asymptote at x equals c, has a vertical asymptote at x equals c if f of c does not equal 0 and g of c does equal 0. Make sure you have that in the right order. If f of c does not equal 0 and g of c does equal 0. We actually did a lot of this last year in pre-calc. What this is saying is, when you've got your rational function here, the asymptote occurs at an x value that makes the bottom equal 0, but doesn't make the top equal 0. If it made the top and bottom 0, that was always a whole. But for the vertical asymptotes, it makes the bottom 0, just not the top. And so, as we do these, I think I've got 3 of these that we'll do together. That's basically our approach. We need to find x's that make the bottom 0, not the top. And so here we go. Find vertical asymptotes, if any, for the function. Find vertical asymptotes, if any, for the function. I put show work. I mean, I know you can see them on a calculator, but you'll have to also be able to do it by hand. So show algebraically how you're getting these x's. Alrighty, here's the first one. This is number 3 on the day. F of x equals 3 minus x over x cubed minus x. Now, this is the first one that we're doing here, so I think I've got some steps over there to the side. I know that we just kind of talked about this, but it's always kind of helpful to have steps in your notes. Step 1, set the bottom equal to 0 and solve. Set the bottom equal to 0 and solve. That's what the definition said. It said that the g of x part was going to equal 0. So, let's do that. X cubed minus x equals 0. How am I going to start to solve that for x? Well, yeah, they have an x in common. So let's pull that out front. Now we'll have in parentheses x squared minus 1 You could actually do a difference of squares right here if you wanted to. I went ahead and just broke those apart and then solved for x. So that is just x equals 0. This, I'd have to add 1 and then square root both sides. That gives me back plus or minus 1. Now, that's not the last thing you do. These are not always your answers here. You also need to make sure none of those values, so this is like our step 2 here, make sure none of those values make the top equal 0. Make sure none of those values make the top equal 0. That was the definition. It occurs at x equals c as long as f of c does not equal 0, but g of c does. And so I'm going to just do this real quick here in my head. If I take this x value of 0, plug it in up top, 3 minus 0 is 3. That's fine. I'm just making sure it's not 0. So this works. Now I'll check the positive 1. 3 minus 1 is 2. That's fine, as long as it's not 0. And then negative 1, that would turn into 3 plus 1, which is 4. So that's also fine. I can keep all 3 of those. Now, once you do all of that work, if you want to check it on a calculator, that's fine. You should be able to see the vertical asymptotes there. But again, show your work as far as how you got those x's. Alrighty, let's try just a couple more. Number 4, f of x equals negative 4x over x squared plus 4. Same deal. I'm trying to find the vertical asymptotes. So, step 1 again is to set the bottom equal to 0, solve for x, subtract 4, square root both sides. Now, hang on a second. We're square rooting a negative. That can't happen. And so that would actually just tell me that there are no vertical asymptotes for that function. Again, show your work. That's not much work there, but show it, and then again, you can always check it on your calculator if you want. You shouldn't see any vertical asymptotes for that one. All right. Now, this is our last example here. Pretty quick. Number 5, and it's a good one. F of x equals x squared plus 3x all over x cubed minus 4x squared minus 9x plus 36. Yikes. 4 terms there on bottom. Well, step 1, set the bottom equal to 0 and solve for x. So we have that entire denominator equal to 0. There are 4 terms up here. Do you remember the special type of factoring that we use when we have 4 terms? It is grouping. Very good. We're going to factor this by grouping. Step 1 is, I don't really have steps written out, but hopefully this will just kind of come back to you. Step 1 is to put parentheses, grouping symbols, around the first 2 terms. Now, what is the GCF of those 2 terms? X squared. Pull that guy out. And now, in parentheses, you just have x minus 4. I like grouping because it always just kind of works out nicely. And whatever you have right here, leave a little bit of room, but you can put it again on the other side. Now, what would you have factored out of a negative 9x plus 36 to be left with x minus 4? Negative 9, so this is where it all starts coming together. X squared minus 9 goes together, and x minus 4 only has to be written down one time. I'm solving this, so you can do difference of squares right there, or you can just add 9 and square root both sides. The other part would just give me x equals 4. Now I'm very happy that the grouping worked out so well, but I can't forget step 2, which said make sure none of those values make the top 0. Let's check. If I plugged in a positive 3, 3 squared is 9, plus 3 times 3, that's going to be 18, so that's fine. Check the negative 3. What is negative 3 squared? 9, but then if this is negative 3 right here, you'll be taking 9 minus 9, which is 0, and you can't have that happen. So x equals 3 is the only one from that part that will work. And you can check the 4 over there, but it should be fine. 4 squared is 16 plus 12, that's not 0. So the positive 4 works, the 3 works. But, and I think I wrote this out over there if you want to put it in your notes, the negative 3 gets thrown out because it makes the top equal 0. If you want to just kind of remind yourself about that, we had to throw out the negative 3 just because it also made the top 0. That is just going to be a hole in your graph, not a vertical asymptote. Alrighty, so infinite limits, finding vertical asymptotes. The assignment is sort of all over the place. It's really not long, but it is all over the place. We're doing from page 105, 1 to 8, 15 to 23, 25 and 27, and then 33 to 35. I'll be around if you have any questions. You still have a little over 15 minutes left.